So we start now. Now let's start with the small exercise. So I'll send you the picture first of the question that we are doing right now. Let's say this is again something which we have already done, but this question is this type of question we have not done. We are just starting with that now. You can say it's a warm up exercise. So let's start. Now you can see here question 12% of students at NCSU are left-handed. So 12% of the students are left-handed. What is the probability that in a sample of 50 students, what is the probability that in a sample of 50 students, the sample proportion that are left-handed is less than 11%? So I have already told you earlier once that if the proportions are given, how do we deal with that? So expected value of P, expected value means mean. So expected value is given as, yes, what is the expected value? Anyone? What is the expected value which is given over here in the question?
Sir, less than 11%.
No, no. See, read it again. 12% of students at NCSU are left-handed. What does this mean? Is this not the average percentage? You can say that average proportion,
Yes, sir.
right? So expected value always refers to the mean value. Okay, but in terms of when it is probabilistic, instead of saying mean value, we say expected value. Okay, so this is given as 0.12 expected value. So we can find out the standard deviation also. Standard deviation p hat will be given by root p into 1 minus p by n. Okay, so what value you are going to get? Tell me the value. Quickly calculate and tell me. Yes. What's the standard deviation?
0.045.
Yeah. So we get it as 0.045 after substituting. Next is, now let's look at the question now. The question says, what is the probability that the sample proportion that are left-handed is less than 11%? So less than 11% means this is 12% over here, and less than 12% is this one. Less than 11%. Sorry, let me get this disturbance over. Okay, so less than 11%, right? So, but the question is, this is a binomial, this refers to a binomial distribution, like probability, either you are left-handed or you're right-handed, right? So considering that ambidextrous is not we are interested in, so only 1 and 0, that kind of probability, they win and lose. So we have to check one thing. What is the value of n into p? What is the value of n into p?
Sir, 6.
So what was the parameter which we had considered earlier, that if n into p is greater than or less than something, what was that? In the last class I had told, no?
So greater than 10 for banana.
If n into p is
Greater than 10.
greater than 10. So, so if n into p is greater than 10, then we can consider it to be you can apply a central limit theorem. Okay, but in this case, it is uh, sorry, it is what's that is coming out to be 6, but it has to be greater than 10, right? Now here that there's the issue. So we can't apply a central limit theorem in this. Although in the example which which is there in the slide, which you all will be looking at later. So there again, it has been considered. Okay, we can consider it once for demonstration purpose, but then my this thing is that don't get misled with that. So let's say we have to increase the sample size. So how much should be our sample size? Should we make it 80? If the sample size is 80, we'll be able to approximate it with the normal distribution.
Yes, sir. Because it will be around 0.96, around
So
10.
let's make it 90 only. Make it 100. That will be easier for us to calculate. So let's make it 100. Why did we make it 100? Because n into p value was not coming out to be greater than 10. Now n is 100. So what is the new standard deviation which we get? So new standard deviation would be,
So 0.032.
actually I tell you what, let me clarify those guidelines. When can we consider binomial distribution to be approximately a normal distribution in the case when if the p-value lies between, I'm giving these are the hard guidelines, so let's follow them. If p-value lies between 0.1 and zero point 0.9, so here the p-value is what is the p-value is 0.112, right? So it is greater than zero point 0.1 and np is greater than equal to 5. So this is the hard guideline. So in this case, actually, it is following the this guideline. It is following. So we can even consider what was given earlier. So I've just clarified this now. So it's okay if we can consider 0.045 also. No issues. Are you okay with this? Is there a doubt left? You must be there. But then what was NP greater than 10? So in case your p-value does not lie in this limit, zero point 0.1 and zero point 0.9, between zero point 0.1 and zero point 0.9, then we have to go for NP should be greater than 10. But if it is lying between zero point 0.1 and zero point 0.9, we can even go for NP greater than equal to 5. Even that is considerable. Okay. So we can consider this one. Now, we say it is normally distributed. So how do I find out the value of Z for this normal distribution? So let's make it. So this is the normal distribution. We want to find out this area. So how do I find out the value of Z? Yes. So we have already known here it is expected value of p hat, which is already given as 0.12, and sigma standard deviation, which we have already found out, and that was coming out as 0.046. So we can substitute the value of Z over here corresponding to 11. So it's on the left side, x bar minus mu 12 I mean 0.1, 11.12 divided by 0.046. Is it it? Is it correct? Big question mark. Is it correct what I've written?
Sir, sigma value should be 0.46 divided by root n.
Is it a sampling distribution? Yeah, it is a sampling distribution. See, it is actually what we have found out, no? We have actually found out root n only. If you look at it, you go above. You see here, this one. It is an estimate of the standard deviation which we have already found out. Are you getting it? It's already, root n is already existing here. So are you again going to divide it by root n? Yeah? Give me answer. Who had, I mean, are you convinced or not? So should we be dividing by root n or not?
Sir, I am not getting it.
See, if it is a sampling distribution, we say x bar minus mu s by root n, right? That's what we do.
Yes, sir.
Yeah. So root n is already, when we have found out the standard deviation here, root n already exists here.
Okay, sir. Okay.
Okay, this is anyway, this formula is applicable for sampling distribution, right?
Yes, sir.
Yeah. So that is fine. I mean, this is fine. No problem with it. Any other problem in this formula? There is a problem. Is this point 11 which I have written over here correct? I mean, you have to be, if I'm saying, if I'm asking something, that doesn't mean that it's definitely incorrect. So, what we want to find out, p hat less than 0.11, right? Which will be equal to probability that p hat minus 0.12 divided by 0.046 is less than 0.11 minus 0.12 divided by 0.046. Okay, so what is this value? What is the value for this one? So that's fine. There's nothing wrong with this. That was totally fine. Okay, so what is the value of z? Minus 0.22. Okay, so what we simply need to find out is probability that z is less than minus 0.22. Now tell me, is it what's the value? What's the value on the left side area?
So 0.41294.
Yeah, Shubhangi, right. 0.4129 is the probability that the sample proportion that are left-handed is less than 11%. Okay. Now we go ahead. So in the slides which I'll be sharing, there are other probability distributions also like exponential and Poisson ratio, Poisson distribution is given. But then since we will not be using directly right now in the course, I'm skipping that part. So although it will be there in the slides which I'll be sharing, but you don't worry about it. You just right now focus on the normal distribution. Now we come to the inferential statistics part. So these are the fundamentals of statistics which we need to know when we are talking about the quality control. Okay, that's why we are doing all this. So we talk about inferential statistics. So it talks about inferences about a population. For example, if let's say question is something like this. Suppose uh, if you sampled weights, let's say you are sort of consumer protection company which goes to, you have seen now people go and जाके shops पे they rate the shops for checking the quality and all, right? So let's say you belong to that team, okay, and if you sampled weights of 36 cans, okay, maybe these cans, in these cans you are selling milk or any other edible item, and they obtained a sample mean of, so let's say 36 cans you took out, you went to a shop, you took out 36 cans, and you obtained a sample mean of 5.97 kg of each can. Okay, maybe that can is of oil or something. Okay, so what would you think, that all the cans which are produced are of this weight? And let's say if you find out probability that x bar is less than 5.97, आप जानना चाहेंगे कि इससे कम वेट के भी हैं क्या, या आप ये कहना चाहेंगे कि you want to find out के with this mean and certain standard deviation, what is the probability that you get cans which are small, lesser than this? So let's say the probability comes out as 0.0038. कि आप कोई shop पे गए, वहाँ पे आपने average weight निकाला, and then you found out what is the probability that how many cans you want to find out कि based on this sample statistic x bar and standard deviation, how many samples will weigh lesser than 5.97 kg? Okay, you want to find out. So we can call this as a rare event. The probability is very small. Okay. While the shopkeeper is claiming that I mean, on the box it is written 6 kg. Okay. So getting a weight lesser than 5.97 or 5.97 less than or equal to is very, very small, that probability. So if you, let's say you want to establish this fact कि जो मीन है वो 6 kg ही है. Getting it? Are you getting what I'm saying? Let me elaborate it again. एक a box है. There is a box of, or you can say there is a bottle. uh, this is a oil. Okay, this oil should weigh 6 kg. Actually it is in liters, so let's say liters. It's a volume, right? Liquid, so liters. It should be measuring 6 liters. Okay, then a team of people went to that shop and say that we want to check whether whether you are selling the material which is of 6 liters or not. Okay, so they opened the cans, they opened 36 cans and found out that how much material is there in that. So they found out on an average the 36 cans are weighing 5.97 kg. So, should they punish him? My question to all of you is: should they punish him for keeping it lesser than 6 kg?
No.
No, sir.
Why?
So because the number of cans which have less than 6 liters of oil is very less according to the probability.
Had it been, let's say, for 5.70, 5.7, should he be punished? Yes,
So
should he
in
be
that
punished?
so in that case, probably would like to find out the probability of having less than 6 liter of cans, like the cans having less than 6 liter.
So how do you establish that कितनी probability होनी चाहिए? So that's to answer this question, that can I make any inference based on simple statistics like mean and stand. So as I've already seen that mean can be misleading. We've all seen that one example which I have given you earlier. It simply indicates that the mean can be misleading, right? So even you can't just simply rely on mean, but you can test it. So it requires testing. So that's what we say is inferential statistics. So we go ahead and talk about inferential statistics then. Okay, to answer this kind of question, we say we have to talk about inferential statistics. We have to talk about inferential statistics. So it talks about statistical procedures with which you can make inferences about a population using a sample. I mean, let's say I propose a theory that right now in India, 60% of people have got infected with COVID, right? So um we can say that it's some theory which I'm proposing. But can I test it theory? Can I establish this theory? Like a medicine which you take. Okay, there are medicines in the market, like 50 mg medicine is there. If you take 50 mg medicine of certain person who are having blood pressure or diabetes, their sugar will come down by this much amount, or blood pressure is going to come down by this amount. Getting it? So how do these people establish that? Any ideas? Or like the vaccine which is tested, on what basis? Because the vaccine is supposed to bring your antibodies to certain level, right? So if the antibody does not come to that level, we say the vaccine fails. So how do they establish that? Because anybody population there are 7.2. How many? What's the population of Earth? Anyone?
More than 7 billion.
7 billion, right? So I mean, you are making a vaccine and then saying that it will be applicable to most of them. So how do you come to that conclusion? So whatever we are going to do from now on, it's on the they everyone uses this procedure only. That's called hypothesis testing, estimation and hypothesis testing. So all the medicines which you take, they come through this. All the quality checks which are happening, or let's say the laptop charger which you have, does it give that much amount of voltage or not? Who's going to check that? Getting it? So how do you establish it? So that procedure we are doing. Estimation and hypothesis testing. Estimation and hypothesis testing. So we all know that what is sampling distribution. So when I can't have the data for the complete population, I use an estimator or a statistic. Estimator like mean or standard deviation. I'm using sample standard deviation or the sample mean. They are statistic coming out of sample. So I use them to make an estimation about the population parameter. Okay, I study the behavior of estimator or the mean. How does the mean behave through repeated sampling? Right, I drew multiple sampling to draw conclusions about the parameter. So parameter is mean. I want to make some conclusion about the parameter. So this behavior of sample is called sampling distribution. Like if I take out 100 samples, getting it? So what I was saying is 6 liters should be the weight of it. So that means that if I take out 100 samples, and among those 100 samples, 95% of the samples, they follow between let's say 5.97 to 6.02. Okay, because we've already known that nothing can be, you can't get an exact value ever. So if I can get these limits that out of 100, 95 samples are going to follow in this range, say 5.97 to 6.02 range, and 5% probably may be outside, then I'm okay with that. I can say that this is something which is acceptable. Okay, so the behavior which we get, this is the behavior which we get is the sampling distribution. Okay, now we talk about estimation of this interval. So I want to find out this interval. How do I find out this interval? So the range of interval is determined, and now I'm interested in finding out the interval within which the population parameter can lie, and I'm okay with that because it is not possible for me or anyone in this world to fill it exactly of 6 liters. Is it possible that if you are filling 100 cans of oil, all those 100 cans will exactly have 6 liters? Exactly. I mean, not even one decimal. I mean, up to
No.
that's not possible, right? So I want to find out this interval, and we call this interval as a confidence interval. Okay, we call this interval as a confidence interval. This is called confidence interval. Now we say, and these points or this area which is outside is called significance level. I'll shade this area. The area which is outside, this area is called significance level. Okay, so let's talk about several cases. So let's say we talk about case one when the variance is known, variance of population is known already. So when the variance is known, let's say I fix it as alpha. This area I fix it as alpha. That is, let's say 5%. So since it is symmetrical and on both the sides, we can, and it is based on the center limit theorem. On x-axis we have x bar. So sample means are plotted on x-axis. Okay, so now x bar we say is the sample mean which is plotted on the x-axis, and I want to find out the limits over here. So how what will be this value? It will be z equal to this. Let's say this is alpha by 2, and this is also alpha by 2, where alpha is the significance level. It is defined by user. This significance level. This is alpha is the significance level. It is uh, defined by the user, and the z value, let's say, is alpha by 2. Okay, so it would be given by x bar minus or plus. Yes. So this is mu over here. Okay, so we can write it. Just let me make it more clear over here. So z alpha by 2 will be given by x bar minus mu by sigma by root n. Okay, or we can say, or, and similarly this side z alpha by 2 will be equal to mu minus x bar by, divided by sigma by root n. Okay, so further we can write, can we not write it like this, that mu lies between x bar minus z alpha by 2 sigma by root n and x bar plus z alpha by 2 sigma by root n. Yeah, actually here there's one change. If we are considering sines, so we'll make a small change over here. Small change. We make this one as plus and this one as minus. This is minus, this is plus. So if we can express mu here from this, mu will be equal to x bar plus z alpha by 2 sigma by root n, right? With this formula. And similarly, other change that we need to make over there on the other side as well. So this will be uh, correct from that. I mean, it will be minus mu plus sigma, x bar minus mu, because negative no on the other side. So then using that, we get this formula over here. Is it clear? Yes. Is it
Yes,
clear?
sir.
Okay. So we get the confidence interval. So when is this applicable? When the population standard deviation is known. Okay. Then only in that case it is applicable. What if the population standard deviation is not known? So this is case 1 we talked about. Now case 2, when variance is unknown. Variance is unknown. So when the variance is unknown about the population, we can't use a normal distribution. So what do? We have to take a sample and then we find out the mean and the sample standard deviation from that. Okay. So in that case, we use a t distribution. Okay. T distribution is exactly like normal distribution, but then the table is different. The function is different, but it behaves like normal distribution only. It is symmetrical across the mean and it is asymptotic to x-axis. Okay. Uh, so again, the same thing happens over here. This is the significance level, and the confidence interval limits would be given by the t distribution. We will be doing that problem, don't worry. So it will be given by t alpha by 2 multiplied with, instead of sigma by root n and comma n minus 1, which is degrees of freedom. So the t distribution is characterized by the degrees of freedom, which is dependent on the number of uh, samples. Okay. So it will be given by s by root n. This one. This is subscript only. This part is a subscript, and this will be t alpha by 2, comma n minus 1 s by root n. Okay. So this is the confidence interval when the variance is unknown. So both the cases we will consider. So let's do a problem now. The problem is somewhat like this, that there's a company trading in China, a New Zealand company is there which is trading in China, and they were asked for number of years of trading in China. Okay. So let's say uh, so basically New Zealand companies are there. The New Zealand companies, they are trading in China. Okay, so they want to know that since how long, what is the average time for which the New Zealand companies have been trading in China. Okay, so they take out an average sample of 44, average sample of 44 companies, and they find out the mean x bar, the years of trading which they have done in China. It's 455 year, 10.455 year is coming. And we assume that the population standard deviation is also known, which is 7.7 years. Actually, knowing how practical it is that you know the population distribute, I mean standard deviation of uh, certain population. Is it practical that you know population standard deviation? How practical is it? So you can say in one way that if it is something recent, okay, and you know that something new has come up just now, and you started taking data of it day and night, all the time you are collecting data of it. So it is quite possible. But if the process is old, and or you something for which you have not kept track, but now you realize that I should have kept track, and this kind of question has come. So you might not know the standard deviation. But for simplicity, right now let's consider we know the standard deviation of the population. So here we can use normal distribution. Two reasons we can consider normal distribution. Reason one, sigma is known. Reason two, n is greater than 30. So we can use normal distribution. Okay, in this case. So if I have to know that, if I want to find out that I want to be 90% confident about the range in which range of the years of trading in China of New Zealand companies, I want to be 90% confident. So can you tell me what will be the significance level? Can you tell me, anyone, what will be the significance level in this for 90% confidence? Yes, anyone? Ashi, you're there? Jaswant, Karvi, Lokesh, Yukta.
Yes, sir. I'm here.
Yes, sir.
So, so tell me what will be the significance level for 90% confidence? I told earlier, if this is the normal distribution and we want to find out the confidence interval. Okay, I want to find out confidence interval in this case about the years around which the companies have been trading in China. Okay, so this 90%, this area, when I'm saying this 90% is the confidence interval, that means this area is 90%. This area is 90%. So what is the, and remaining part is the significance level. So this area, which I have just shaded here, this is the significance level, which tells that there are 10% chances that whatever I'm going to interpret about the mean may not be true. That is 4.5, mean may not be 4.55 for these companies which are falling in this region. So this reflects, so here in this case, the significance level is 10%. Okay, so how 10%? 100 minus 90. So this area is 90, so whatever is left is the significance. Can make wrong conclusions in the significance level, in the region of the significance level. So 90, but it basically means that if I take 100 companies of and say that these companies have 10.455 years of experience, okay, around. So I'll also say with the confidence interval. But among these 100 companies, there is a possibility that 10% of the companies may not have, maybe outside that range of confidence interval. Okay, getting it? So
Yes, sir.
I want to find out the confidence interval for that is, I want to find out this mean is true in what range? Okay, so this mean is true in the range x minus z alpha by 2 sigma by root n, and x bar plus z alpha by 2 sigma by root n. That's what I'm interested in. Now, can you find out this value quickly, all of you? Yes. How many of you are finding? Please raise hand. Please raise hand if you're finding.
Sir, can you scroll a bit up, like the values?
Okay. Is it okay?
Yeah.
Yeah, please update if you're complete. You have completed. Post your solutions in the WhatsApp group. Yes, Yukta, Jaswant, Shubhangi, Karvi. Are you facing any problem in doing this?
Mm. Yes, sir.
Okay, so now let me explain you what's the problem which is coming. Let us see that. So x bar we know already. X bar is known as what is the x bar which is given? 10 point
455.
10.455, right? Minus z alpha by 2. Can you tell me corresponding to 5% here and 5% here, what will be the value of alpha, or what will be the value of z? Z corresponding to 5% here. Let's say this we want to find out. Z alpha by 2 value, can you tell? Look into the normal distribution table and see where is point 0.095.
Sir, 0.82894.
Hmm? Z value corresponding to 95%. See, this 5% mean this area is 5% means this area is 95%. Okay, so we look for Z value corresponding to where the area is 0.95 or approximately 0.95.
So one
1.65
point,
or
yes, sir.
96.
So 1.65.
1.65, right? So 1.65 multiplied with sigma is given as 7.7 divided by root n. So root n is 44. Less than equal to mu less than equal to x bar is 10.455 plus 1.65 into 7.7 divided by root 44. Now tell me, what do you get? What is the range? Calculate it quickly. This you can do it.
So 8.54 to 12.37.
8.54 and 12.36, right? So
Yes.
this is the range. Now, what is the meaning of this range is that as long as the mean of any sample which I draw, let's say I draw 100 samples, out of those 100 samples, 90 samples will have the mean lying between 8.54 and 12.36. Okay, that they will correspond to a population which is having a mean of 10.455. Are you getting it? So when I'm saying this sample is having a mean of 10.4, or this population is having a mean of 10.455, it basically means that it's not necessary that every item in that sample will be weighing 10.455 or in this case 10.455 years. Not every company is going to have exactly same uh, value, but this average corresponds to a population which varies between 8.54 to 12.36, and it is acceptable. But 10%, I mean, 10% samples will be there which will be falling outside 8.54 and 12.36. So we are 90% confident about this sample mean 10.455 with this confidence interval. Are you able to get it?
Yes, sir.
Yeah, so I suggest you go through this presentation again, go through the lecture again. I'll upload the video, and probably you will be. I suggest whenever you are solving this kind of question, tell it to yourself again and again that this is what it means. Otherwise, no, you'll fall into a trap of calculations. You get a mathematics syndrome where you just keep on doing calculations, but you don't know what's the physical meaning of that. That is very important. You should know it. Okay, so we conclude for today. If you have any doubts, let me know and give your attendance.